In this video, we will check the different components with the help of digital multimeter. So first of all, we will check continuity of this wire with the help of multimeter. To check the continuity of this wire, we will rotate the dial to this buzzer position. As you can see, a buzzer or diode symbol is mentioned here. So with the help of this position, you can check your continuity of the wires. Now, as this wire is okay, buzzer will beep. Okay, and if it was broken inside, the buzzer will not beep. Next, we will check the LED. This is the light emitting diode and it has two leads. The longer one is positive lead, or we can say anode, and the shorter one is cathode. So what we will do? We will keep the socket to the voltage ohm position and another to the common position, and now I will connect the red lead of the digital multimeter to the positive lead and black lead to the negative lead. The LED is glowing. I hope you can see the glow of the LED. So it means it's a correct LED. Now what happens if I correct in the reverse direction? The display will show OL. Means I have reverse biased the diode and it will not show any value. Okay. So in this way you can also check the positive and negative lead, and you can also check whether a LED is faulty or correct. So we can find out the resistance value with the help of the color coding system also, and with the help of the digital multimeter also. First we will rotate the knob and put it to the correct position in the ohm meter range. Okay. And as resistance does not have any positive and negative lead, you can connect the wires to any side. Also through the color band you can find out green color is for digit 5 and brown color is for digit 1. And red color is multiplier, so it is for 10 raised to power 2. Okay, so its value is 1 into 10 raised to power 2 means 5100 ohms. It means 5.1 kilo ohm. So theoretically also you have find the value, and with the help of multimeter also we have find the value. It is showing around 5.08, which is 5.1 kilo ohm only. So this is showing the correct value. Next we have a transistor with us, and its value is BC557. Now I will try to check whether it is a PNP type transistor or NPN type transistor. So what I will do, I will simply connect red lead to the outer lead and black lead to the center one, and rotate the knob to the diode position. So now you can see, by connecting the red lead to the outer lead, I have forward biased this section, and it's showing forward voltage drop of 0.7. It means this lead is P type and the center one is N type. So from here we can know that this is PNP. It's a PNP transistor. So now we are going to check PN junction diode. So as you can see in this diode, here we have a silver band. Okay, so this silver band side is cathode and this side is anode. So what we will do, we will rotate our knob. We will rotate the knob of the digital multimeter to the diode position, and now we will connect it in the forward bias condition. So we will connect the red lead to the anode side and black lead to the cathode side. And as you can see on the display, the reading is 0.558. So breakdown has occurred because I have forward biased the diode. So if it is showing this much value, this much voltage drop around 0.6 volts, so it means it is a correct diode. Now if I reverse bias it, I connect the red lead to the cathode side and black lead to the anode side, it will simply show OL. Now because of the high resistance of the reverse bias, this display will not show any reading. So this indicates this diode is fully correct. Now this is Zener diode, this tiny one, orange and black in color. This black band shows this is a cathode side and another side is anode side. So in forward bias condition, if I forward bias it by connecting anode to the red lead and cathode to the negative lead, it will show a voltage drop of 0.6569, means around 0.7 volt. So it will work like a PN junction diode in forward bias, but when I reverse bias it is showing OL. This is because of the reason its voltage drop might be greater than the internal battery value of the digital multimeter. So when I reverse biased it, because of the high resistance, it is showing OL. Okay, so in this way you can check whether component is faulty or correct one. So this is also correct one. Next we have electrolytic capacitor. As you can see, its one lead is long and another is short. So longer one is positive lead and shorter one is negative lead. Negative sign is also mentioned here. We have already checked the value. Value is already printed on the capacitor. It is 1 microfarad capacitor. But if you want to check whether it is faulty or correct, you can also check with the help of the multimeter. So I will simply put it in the socket like this, and I will rotate the knob. Now you can see it's clearly showing 1.0, means it is 1 microfarad capacitor. As it is showing the value, digital meter is showing the value, this capacitor is correct, not a faulty one. So thank you so much everyone.